Hello.
Hello, everybody. Welcome to the webinar.
We are still waiting a little minute so everyone can connect. Sorry, I just a little minute and then we begin this webinar. Okay, so I'm going to begin and people are going to follow. So hello everyone, we are here to talk about co-processing today. And to talk about it, we are here with Nicolas Martinez, who is Sustainability Project Manager at 2BS, Conrado Gattoni, Senior Project Manager for 2BS, and myself, I'm Marine Caffio, and I'm a Content Assistant. So just a little reminder before we begin, this webinar will be registered, so the transcript will be available on our website and they will have a Q&A. You can ask a question on the chat and we are going to answer to your question at the end, so you can ask on the chat and we will answer it. So today we are going to make a little introduction about 2BS, an introduction about the co-processing. We are going to talk about the scope of certification, then the technical part, and as I said, at the end, we will make a question and answer session. Sorry. So before we begin, we would like to know you better. So I let you scan this QR code and answer the question, or you have the link, just you can enter the number to answer the question. I let you scan the QR code. I give you a few minutes. Or here you can join the Slido with the QR code just on the corner of your screen. You can join the Slido with the QR code or the number just in the corner of the screen. I don't know if it's working correctly.
So you have these questions and then you choose your answer, and like this we will have a feedback about what is our public, and we will adjust the content accordingly to. So there is 8 people already.
Yeah.
If you go next one, I think that we will have the results.
Yes, the result for the other one.
Okay.
So most of the people are already certified.
No, not certified.
Not certified, sorry. Yes.
Okay, but there is some that yes. Okay, interesting.
And the other one, I don't know if it's working. We are going. So many of you are not certified. Thank you for your answer. So, and we would like to know who you are, although it's interesting for us to adapt the content.
I think you can click here.
Yeah, we are going to continue, and then we come back to this question.
Just click this next one so we can see the results.
Thank you. So we have consultant, lots of other auditors, lots of auditors. Thank you for answering. So I'm going to begin. So I'm going to talk about the RED, because we are going to talk a lot about that during this session. So what is the RED? It's the Renewable Energy Directive. Our certification complies with with the RED II. So here we are talking about sustainability according to the European Commission. The purpose of this directive is to reduce green gas emission in the Europe and to promote sustainable energy. To achieve this goal, the European Commission has published objectives and requirements to follow. The RED also defines what sustainable raw materials and products are within energy market, but Nicolas will talk about that later. So we, TOBS, we are an association, no-profit organization. Our guideline covers the entire chain from the first collective points to trader and processing units. We support our customers in demonstrating their compliance, giving them access to different markets. We have more than 1,000 certified in Europe and Latin America. So the certification, as I said, has complies with the RED II. Our certification is valid for 5 years. And we are working with reference certification body. And the most important part, we are recognized by the European Commission. So you can sell your product under the sustainable label. So to be clear, the European Commission published the directive. We translated into a documentation with audit sets of requirements certification. Then we recognize a certification body to carry out your audit. Once the audit is approved by a certification body, we receive a validation that allows us to issue a TOBS sustainability certificate. Even though the certificate body conducts the audit, you will receive TOBS certificate. Nicolas, I give you the hand.
Thank you so much, Irene, for this introduction. Well, I'm going to give another introduction, but more in detail about the technical part in our scope of certification. So, do you see my screen and my mouse too? Is it okay? Yeah. Yes. Okay, perfect. Thank you. So the certification scope of the TOBS concerns biomass, fuels, and bioenergy production from the raw materials that are agricultural biomass and waste and residues, and biofuels, bioliquids, and co-processed fuels, also coming from agricultural biomass and waste and residues. We are waiting for the recognition for the use of wood forestry biomass as a raw material. For the moment, we're not recognized yet, but then it's ongoing. So it can be at any moment that we will extend our scope of raw materials accepted within our volunteer scheme. And we are also waiting for the recognition for the RED III, so the revised RED II directive that is going to be in application from May 21st of this year. Now I will do my laser. Yeah. So we're going to talk about more the co-processing because this is the topic of our webinar. The documentation that you can read to have more details about the requirements to be compliant with and how the audits happen can be read in these two documents in our documentation. The standard number 2 and the procedure number 6. The standards are like the checklist of the auditors, and the procedure is a more detailed document that explains how the specificities of co-processing. The procedure incorporates the following provisions, so you may be also acquainted with these two documents: the implementing regulation 2022/996 that has a chapter on it, specific rules for co-processing, and an implementing regulation 2023-1640 about this as well. So as you know, co-processing refers to an oil refinery unit that processes, in addition to the usual fossil feedstocks, you can also have a biogenic part that is in the feedstock. So at the end of the processing, of the co-processing of these two feedstocks, we will have fuel from which a share is going to be biogenic, thus it's going to be considered renewable, and it can be claimed as that. To do that, you have to be certified and follow the requirements of the RED II. It is important to note that in our documentation, RCF, so recyclable carbon fuels, and RFNBO, renewable fuels of non-biological origin, are mentioned in relation to this processing, this co-processing, but additional methodology is required to address these two types of fuels. And our scope of recognition doesn't include these two yet. It's one of our projects, and it's going to be in 2025. We're going to extend our recognition for these two fuels. For the moment, it's only for biogenic, for example, oils or waste and residues that can be used as raw materials. And talking about the RED more in general, the main two pillars about sustainability is the eligibility of the raw materials to be part of the supply chain and the greenhouse gas emission savings. So concerning the eligibility, see if it's energy crops, they must come from sustainable land. The collection of agricultural waste and residues does not affect the soil quality or soil carbon stock. And if it's waste and residues, they have to meet the definition of the Waste Directive 2008/98 and comply with the waste treatment hierarchy that we're prioritizing recycling, etc. Concerning the greenhouse gas emission savings, you may have already known this, so we have to confirm that the greenhouse gas emissions that we emit to produce these biofuels is much more lower than the fossil analog. So there is a percentage that is stated in the red about this. To compare that, this is why we have to calculate then the footprint of these fuels, on these biofuels, to be sure that we meet this criteria and we're having a positive impact on global warming. Now, let's talk about the scope and more the certification of the actors of the supply chain. As you know, if we talk about waste, oils, or fats, waste and residues, arise at the point of origin, so the waste producers. Then there is a first gathering point, so the first entity in the supply chain that is going to be certified and is going to analyze and confirm the sustainability criteria from these feedstocks that are collected. And afterwards, these feedstocks are going to be transferred to the next actors downstream in the chain. They can be traders, they can be processing units, or other actors that can process them into intermediate products. And afterwards, these processing units, the last interfaces, are going to produce a fuel, in this case, a co-processed fuel. There is two standards in our scheme, in our volunteer scheme. The standard number 1, that is for the collection of raw materials, and the standard number 2, that is for all the actors afterwards in the chain. So the standard 1 for the first gathering points, they concern the collection of non-certified materials. So as you know, you see here it's black and it becomes green. So the first gathering point is going to ensure the sustainability criteria of these non-certified materials, and it's going to emit these declarations, the sustainability declarations, to prove the conformity to the RED. Afterwards, there's the point about the audit of the central office. So a first gathering point is going to have maybe some logistical sites one certificate is issued per legal entity, per main certified unit. This can cover all these certified units in logistical sites. For the standard 2, there is the collection of certified materials. So for example, for a trader, it's sourcing its materials already certified. So this is going to be standard 2 that is applied. On-site audits for the processing sites, and only one certificate is issued per processing sites. These processing sites can also have as well logistical sites. So this is going to be covered by the certificate, but then only one processing site can be in one certificate, and on-site audits are compulsory. And after that, we have our product that is going to have a part of biogenic material. Concerning the greenhouse gas emissions, you know that in the case of waste and residues, they are considered to have zero life cycle emissions according to the RED. So then there is going to be only the emissions due to the transportation from the point of origin to the actors in the supply chain. The first guiding point, the same, only transportation. And afterwards, the traders or the actors in the certified in the standard 2, they are going to have the EP, so for the processing itself, the emissions that were emitted for this. Here you have a diagram of the whole supply chain, an example of it. So if you are a refinery producing biofuels, your suppliers may be traders or other processing plants. For example, if you use virgin oils, then there's going to be the point of origin is going to be the agricultural sector. If it's waste and residues, it can be restaurants, industries, eco-organisms, collecting used cooking oils, etc. These points of origin, they will transfer a sales declaration to the first gathering point. This is the actor that is the first actor that is certified in the chain. These can be cooperatives in the case of crops, or treatment and storage facilities for waste. And these actors are going to transfer a sustainability declaration to the trader or processing unit in the supply chain downstream. And afterwards, another sustainability declaration if applicable. A little reminder, households or particular people, they're not point of origin. The point of origin in this case is going to be the first actor that is collecting these wastes, for example, municipalities or eco-organisms in the case of collectors of used cooking oil, for example. This is a scheme of your suppliers. What is the scope of their certification? So for the first gathering point, there is a main certified entity who has several collecting points, logistical sites, service providers, if there is transportation involved, and the collection of this self-declaration from the point of origin of these wastes. There is one certificate, and then there's going to be a group audit to verify the sustainability claims of these point of origins, as well as the compliance of the logistical sites. This entity issues a sustainability declaration for each batch. Then you have the processing units that would describe these co-processing refineries, for example. There is a standard 2 certificate, and the scope of this certification can be service providers for transportation or subcontractors, and logistical sites as well. You will receive the documentation from your actor upstream as a sustainability declaration for each batch. And for the production of the biofuel, you will issue a proof of sustainability that is going to be attached to the batch of biofuel produced. Now I will give the word to my colleague Conrado about raw materials.
Thank you, Nico. Okay, let's move forward on this section. We will also discuss the criteria for raw materials requirements and the management system needed to ensure compliance. Just for clarification, this chapter may sound familiar to some people because the basics are the same as what you already know, according to the standard 1 and the standard 2. Please, next slide. Well, starting with this section, we'll move on the management system chapter, which falls under Principle 3, Criteria 3.1. This chapter defines the essential requirements and procedures that economic operators must implement to ensure compliance with the 2BS voluntary scheme. As you can see in the checklist image, the key components are as follows: documented procedure. The first one, eligibility review of biogenic feedstock and the inspection of records. These three components are critical in maintaining the integrity and sustainability of the certification process. The checklist in the image at the bottom provides a visual reminder of these key criteria, ensuring that we cover everything necessary for compliance. Sorry. It's important to note as well, this is type of add-on of the management system, which may have already been developed previously. If you are certified, you must be aware of it, and essentially it builds upon Principle 0 of the Standard 1 and 2, incorporating the indicators you are already familiar with. Next slide, please. Okay, the first point of this principle, within the procedure to be developed, the economic operator must have a documented procedure, and the economic operator shall develop a mapping of processes and facilities, like a flowchart, plant layout, and facilities involving the scope mainly. The specify start of operation, considering the production of the first batch with any feedstock eligible for co-processing, and provide a list of all covered sites. This is a list of sites similar to the traditional Standard 2 processing unit. Just to keep in mind, the conversion factor, I mean the methodology, must be declared and described in the procedure. It cannot be modified unless previously authorization by the auditor. And in this stage, when we refer to auditor, we mean saving evidence of contact and reliable authorization from the audit team of the corresponding certification body. Next slide, please. Okay, the second one, maybe it's familiar, but the economic operator must ensure that the eligibility of the feedstock is a reliable process to ensure that the raw materials used in co-processing comply with the sustainability criteria. Therefore, this graphic highlights the key difference in what is required for each category, which is essential to ensure such compliance. Sorry. For example, the raw materials, the first one, and as you know, this category requires compliance with sustainability criteria land, which is stated in the Standard 1, and GHG savings, of course, and this ensures that the materials used are sustainable and contribute positively to reducing emissions. Then the primary residues, as residues of the agriculture, aquaculture, fishery, and forestry. These materials also need to meet the sustainability and GHG saving criteria, but in addition, we must define what constitutes a residue as well through a decision tree, first of all. And this is very important for distinguishing between materials that qualify as residues and those that don't. And the last one, non-primary waste and residues. For this category, the same sustainability and GHG savings criteria apply, but without the sustainability component for the residues themselves. The focus here is primarily on GHG savings and the correct classification of the materials, such as industrial waste, household waste, and municipal solid waste, for instance. One thing else important to take into account if we talk about waste and residues, the waste hierarchy must be respected always, such as the directive requires. Additionally, it's important to stand out also that the waste must not have been intentionally altered or contaminated to fit the definition of waste. This is a critical non-conformity, as you can imagine. This ensures that the materials being classified as waste are genuinely waste, not modified to qualify for a specific treatment or recycling process. You can determine if a material is a waste, residue, co-product, or main product by the decision tree. But just know that if there is a doubt of the classification of a material on this topic, you can always check the Pro 04 about waste and residues mainly, or check with us directly by writing an email. Next slide, please. Well, the third point in the management system to take into account in this procedure is the indicator 3.1, the inspection of record mainly, which concerns the inspection on record, which is also intrinsic to internal reviews and monitoring activities that must be carried out annually. And it's likely that you already know, because this is into the internal reviews that you perform annually. Even though this scope requires a stringent review to avoid mistakes. And in order to comply with, the economic operator must apply the caution principle, like the standard one in the principle 0, when necessary, excluding non-compliant feedstock or under doubt of eligibility, as well as conduct an assessment that includes detailed records of biogenic feedstock, test results, and mass balance calculations. These specific topics should be verified by the auditor, and for example, such as the warning mentioned, the warning mentioned that you can see in this slide, which says the samples related with the co-processing quota claims shall be kept for at least 2 years, along with the associated measurement records and calculations. In order to move forward with these specific topics, Nico will provide more technical details in the next chapter, I think, regarding the points I've mentioned.
Do you hear me? Is my microphone still on? Okay, perfect.
Yes.
So now we're going to talk about conversion factors, mass balance, and traceability. So how do we determine the share of biogenic carbon, so of this renewable biofuel that we're going to produce through co-processing? The method preferred by the European Commission is the radiocarbon dating. As you know, is a method that will measure the radioactivity of C14, that will give us the idea of how much is biogenic and how much was from fossil carbon. This method is mandatory according to the Commission, and the issue with this is that this radiocarbon dating is expensive, requires specialized labs and equipment, making it costly compared to other carbon tracking methods, and time consuming. The process takes days, 2 weeks, which is impractical for routine certification. So maybe there's some actors that will have radiocarbon dating in their facilities, but then this is not very common practice. So the Commission allows to figure out these conversion factors and this biogenic part using other methods. So how do we determine this biogenic carbon? We have here the example of a refinery using fossil crude oil and vegetable oil. At the end, as outputs, we will have some gasoline, some diesel, and some kerosene. And as you see, there is going to be always a fossil gasoline and a biogenic gasoline. There is fossil diesel, biogenic diesel. So the thing that I'm trying to explain is that the free allocation of biomass into the products is not allowed. You cannot say, oh, I have 5% of oil, so 5%, I am going to say that all my gasoline is biogenic. You cannot do that. The biogenic share is going to be distributed among all the products. And specific conversion factors are going to be made for this reaction. So this vegetable oil is going to convert in gasoline, diesel, and jet kerosene in this example with different conversion factors. And there is going to be also a share of the emissions, like not only CO2, there will be also CO and H2O that are going to be attributed to the biogenic part. So in case of multiple products, distinct conversion factors must be established for each product from each raw material. And also biomass must be attributed to all products, including carbon monoxide, carbon dioxide, and water, as I just said. So everything is distributed among all the products. Conversion factors may be specified in national legislation. So, for example, in Italy, reference conversion factors. So the government has already studied these conversion factors, and then they can be used by default. We will talk about this a little bit later. And then, as I said, C14 radio dating is the preferred method for the Commission. So we will measure this biogenic part of each product and have a percentage of the share. So how to have these conversion factors? So how to say how much vegetable oil converted into diesel, into jet fuel, etc. You have the 4 options, a mass balance that is going to have anyways the C14 analysis, but just for calibration and rectification every 4 months. Energy balance also with C14, yield methods, and just the use of the mandatory method C14 if you have this possibility. So let's talk about this conversion factors methodology for each of them. So mass balance methodology has the idea of the mass, right? So well, the name it says. So if we have fossil crude oil as an input and biogenic oil as another input, then we have a fuel, a product. We measure the mass. What is going to be this mass? So we're going to perform C14 and calibrate our mass balance method so we know that the biofuel that we did has 30% of certain biogenic. But as I said, is a mass balance, and you cannot attribute my biogenic only to one product. Everything is divided among all the products. So the mass balance, so the equivalence in both sides of the equations, is that here there is 20% of biomass in the inputs. So the hypothesis or the idea is that at the end you will have 20% of mass of biogenic feedstock, well, of biogenic source. So this includes the mass also of off-gases, of liquid industrial wastewaters, of residues. So everything will be taken into account mass-wise, and this 20% will have to be proportional to this 20%. So as I said, this method can be used and will be rectified always by the C14 radiocarbon method. The second method that we're going to talk about is the energy balance methodology. So instead of mass, now we talk about energy. The hypothesis, the idea about this method is that the energy, the biogenic energy in the input is going to be equal as the bioenergy in the output. So we will convert all these inputs using the lower heating value to our megajoules, and we will have a total of megajoules from which a part of it is biogenic. So in this example, we have 54% of megajoules that are biogenic. These units are just for examples. For sure, they're not kilograms or megajoule, but yeah. So 54% is in input, 54% of the energy output has to be considered to be true. So we have the megajoules of the of gas. So that's going to be less energy because like CO2. What is the energy content in that? Not much. So that's the energy balance. Energy of inputs equals energy of outputs, and this method will have to be calibrated and verified and rectified by C14 method. Next one is the yield methodology based on experimental conversion factors. So as I said, if a country, if a member state has defined already a conversion factor that has to be used within its territory, it can be used by the economic operators, by the refineries, as default conversion factors. So, for example, in the case of Italy, for a hydrosulfurization plant, these are the conversion factors. For rapeseed oil, used cooking oil, we will have these bio outputs and these values that can be used right away by the economic operators as default, already not taking into account the other products. It's just by default. It will have to be officially recognized by the member state, and these calculations and values are validated by the Commission. The incremental yield change methodology consists of comparing. So in a scenario where we have 100% fossil crude oil being transformed, processed to diesel, and then we do a second scenario where we inject a quantity of biogenic oil, then we identify the increment, the difference of the product mass, and then we will see that these four, so it was 60 when we were 100% fossil. Now that we have co-processing, we have 64 of diesel. So we can say that these 4% are biogenic. So the radiocarbon 14 method, it will be used to verify the correctness of this method. And as well, if you have several data or several batches that have been done with specific conditions, and you can link the biogenic oil input with the output of a certain amount of biodiesel. This can be done, but several batches have to be produced to have enough evidence that will be presented to the auditor. Everything is based on the accuracy, on the reliability, the evidence that you can provide about the methodological choice that you take into account, that you apply. And then at the end, you have a C14 analysis. So these economic operators that that will have to check this C14 have to apply the accelerator mass spectrometry method. If the bioshare is expected to be at least 1% of the volume, they may alternatively apply the liquid scintillation counting method. For the labs that do this analysis, they have to be certified with these different standards. You can find more details in our documentation. Then the testing may be conducted either by operators themselves if they have their own laboratory on site, or by accredited laboratories. And this accreditation of laboratories will depend on the country that you're in. So in France, it's COFRAC, UCAS, DAX, etc. And just it's important to remember or know that C14 radiocarbon testing is commonly not compatible with gaseous products, for example, bio-LPG. Therefore, extrapolation of biogenic content can be extrapolated. Yeah, so it's allowed to do these extrapolations. Experimental measurements conducted on pilot plants using individual components or model systems related to coprocessing facility are permissible in the initial certification process, but then they have to be verified and with supplementation of the field evidence obtained during the actual co-processing phase in the plants. Well, as I said, this is the implementation that governs these rules. And if the production system co-process new renewable hydrogen of biological origin, then we have to make sure that no double claiming, no double counting of this hydrogen is taken. So this is the responsibility of the economic operators of how to prove to the auditor that you're not doing this, that this renewable hydrogen is not counted as renewable elsewhere, and that the actual hydrogen was used and implemented into the co-process fuel. So that's quite logic. There's further details about this measurement. So if the radiocarbon test method is used as a second method, so in the case of mass balance, energy balance, or yield methods, then a deviation of more than 1% in absolute terms for the result of the main method used is accepted. So this is the maximum. Deviation of more than 1% would be considered not valid. In the initial year, it's accepted for 3% of deviation because it's while you calibrate your method. So for sure, there's some flexibility. But then when we talk about sustainability in co-processing, it's always about compliance with the rectification of the primary test method, the identification of any systemic errors and the correction of them, and the calibration of this method if we have these deviations. So as I said, this radiocarbon 14 is going to be used in any case to verify it, and it has to be applied at least once every 4 months. So to be sure that the method is not that is always consistent. And whenever a change occurs in the composition of the raw material higher than 5% versus the reference condition, so that's the thing. Always is a methodology is defined for a certain condition. If a yield has been defined, is always taking into account the condition, the specific condition for which it was obtained. So if there is the share of biogenic inputs that changes, the quantity of hydrogen in catalyst in the total mass, process parameters like temperature, pressure, composition of the product, etc. So this radiocarbon method has to be applied to corroborate what are these new conditions to rectify. But there is this little asterisk: unless the applied method can identify the operating conditions relating to biogenic content in the output of each batch. So it means that if you have enough evidence and you understand your processes that well, that you can predict that if you change this parameter in this way, you will have this increase, then this can be accepted. But then again, you have to compile the evidence and the arguments to be able to justify it. The methodology shall be clearly stated and described, as Conrado was saying. It shall not be changed unless authorized by an auditor. So 3 reminders for the economic operators that do co-processing is to keep the samples at least for 2 years concerning all these biogenic co-processing batches, provide certification bodies and auditors full access to these samples, records, and methodologies, and make available the detailed description of the main test method used, including indication of the accuracy and precision, also verified with the radiocarbon. So everything has to be just in this way that the methodology is clear, the hypotheses are argumented, etc. Concerning the mass balance system, so already it's not mass balance method for the conversion factors, but the mass balance system. What is the mass balance? Is the following the flux of feedstock and output. So we're going to only look at the renewable part of it, right? Because we are certifying only the biofuel. So we will have the information of the greenhouse gas emissions of the feedstock, the documentation that comes with it, the sustainability declaration, and the type. And we will have this system that we have these inputs that are entered into the system, and then outputs how much of this biodiesel, biokerosene we produced. So with their own specific characteristics as greenhouse gas emissions for the processing step, the POS, so the proof of sustainability that you have to issue to the client that you sell, and what type of product. So the conversion factors that we were talking about, they have to be used. And the rules about mass balance, you can find them in the standard number 2.2. So the economic operators must avoid risk of deviations and facilitate an ex post audit of claims relating to co-processing and the biogenic share of their fuels. Apply a global mass balance system indicating the biogenic share of inputs and outputs. So just to follow, have the traceability of how much you received of sustainable feedstock and how much you are exporting. The mass balance calculation is in parallel with the main test method, so they're linked because you will have to know how much of this product was produced from this input. And when blending co-processing outputs with other fuels within the refinery or other co-processing facilities, use of a mass balance system that allows batches of fuels derived from fossil fuel treated biomass to be blended with other fuels in a common process while providing adequate information on the characteristics and sizes of the batch. So you have to be traceability is the key. So you have to have the fluxes of all the if it's the same product in same facility, you can also join these mass balances. Usual rules for mass balance system operate, so separate mass balance for each type of biomass. If you have waste animal fats and then HVO, etc., you have to keep one for each type of biomass. For different product groups, greenhouse gas emissions averaging is prohibited. You have to have these rules are common and described in the standard 2. And the mass balance at the level of the container facility distribution infrastructure. So everything is as normal. I just this slide is repeating the rules, and this is the scope of the processing unit. So these logistical sites are the ones that are going to be the mass balance at the level of a container or a facility or a distribution infrastructure, you can organize your mass balance according to these rules. And now we're going to talk about the greenhouse gas emissions methodology. So as you know, we need to compare biofuels and fossil fuels to be able to claim that we're generating a positive impact. So in the co-processing scenario, you have the upstream reagents, the extra reagents that you use for your co-processing, the emissions from the co-processing itself, the transport as usual. Here, the extra reagents is any reagents with their upstream emissions, so with the factory that created them, the footprint that they have. For crops or vegetable oils, they will have the extraction and cultivation of these crops, the land use change, if it was, etc. So everything that we got into the virgin oil. And for waste and residues, as I said, are considered zero, but the transport of it has to be taken into account. And the CO2 of the co-processing unit must not be taken into account into the calculation. And the e-processing for the very process of production shall be the comparison of 100% fossil fuel compared to a co-processing scenario. We compare the emissions, and then we will share the emissions accordingly to every product. But very important, biogenic CO2 is excluded from the calculation. Now I give the hand to Conrado for the last part, the documentation, and the last chapter.
You can share, you can see my screen.
Yes.
Perfect. Well, finishing this webinar, we move forward in the last two chapters. In this chapter, we provide an overview of performing sustainability declarations, POS, proof of sustainability, even though there are not many relevant changes to take into account regarding the standard 1 and 2. So, well, the transfer condition, the initial conditions remain the same regarding the overall requirements which concern everything in the point of origin and first gathering point, as you can see in the left. But in the case of co-processing, much stringent accuracy is needed to avoid mistakes when issuing sustainability declaration and or POS. This is because the biogenic carbon must be correctly distinguished from the fossil content. For example, if we have a processing unit, whether it's a processing unit or only a transformation unit, as you can see in the chart, some materials may be sold and delivered with a biogenic component. Therefore, it's crucial to cross-check the quantities with the mass balance credits and verify the traceability documents. I mean the POS or the sustainability declarations, invoices, delivery documents, etc. That support the delivered batch. And well, the sustainability and GHG characteristics, of course, must be transferred along with the physical material being passed down the supply chain. So let's review another example in the next slide. Yes, well, here we are highlighting one of the most important indicators in the principle 3 of the updated standard 2, which applies either for transformers and the last interface mainly. So this indicator, by the way, is critical, mentions the following. The economic operator must ensure that all traceability documents accurately reflect the biogenic content and compliance with sustainability criteria for each co-processed batch. Therefore, with this example, intuitive and simple example, we can see that during the review, the economic operator has stated that for the batch A, the 65% of the quantity correspond to biogenic content. So how could they provide the reliable evidence during the audit? Well, through a detailed cross-checking, as I mentioned, of delivery documents, mass balance, invoices, and the sustainability declaration, or POS when needed. I'm sorry. So, in conclusion, to assure conformity, it's important to keep in mind the next. Review the sustainability declaration, POS, issued for co-processed batches. Cross-check the records with the mass balance and ensure the inclusion of all required information in the traceability document. Well, the last chapter today is the audit requirements. Getting into the last section, we have the additional specification of the requirements for applying the co-processing scope. Mostly we have already discussed during this hour, but here we are going to dig into the specific indicators. So let's talk about the additional requirements. This section outlines and reinforces the audit requirements specific to co-processing plants, detailed in our Pro 06 we developed shortly, serving as the basis to make these requirements auditable. So far we have the principle 1 and 2, as you know, but from now on, the standard 2 has included the principle 3, which is familiar, is similar to those for other processing facilities, but with additional specifications aimed at this scope. So on one hand, we have the principle 3, as I said, which contain 5 criteria and indicators, key indicators. The 3.1, the management system that we've been talking about before. The 3.2, testing accuracy, 3.3, mass balance, and 3.4, traceability that Nico explained perfectly before, and which is the most important topic in the co-processing about the methodology mainly. And the 3.5, well, the GHG calculation, that is more like a conversion factor indicator rather than a GHG calculation that is very, very important to mainly in the inspection records as well. So on the other hand, we have the Pro 06. Let's take a look at what it's about. This new procedure, as I mentioned, outlines all the requirements taken into account to extend the standard 2 scope. And the Pro 06 has added 4 specific requirements, which are at the beginning, validation of the applied methodology with control testing and the type of analysis used, as Nico explained in the chapter 4. Secondly, the treatment of deviation, important paragraph at this stage, and any changes errors, inaccuracies that result in a deviation from the previously step must be treated as a major non-conformity. Then the consistency with the industry standard. The final values are based on certified and approved methods with typical ranges derived from industry standards and case studies. And finally, we have in this topic the verification of feedstock, which helps confirm the reliability of data related to the inputs and outputs of the co-processing plant. Keep in mind, if you have any doubts or want to dig deeper into these important points, you can refer the chapter 7 of the Pro 06. Well,
Thank you, Conrado. I'm just going to end this webinar with showing you how to register on our website, because it's a bit complicated for now, but it's going to change. But just so you know, so if you want to register, first you can go on our certification body page to show our references certificate body. Then you have to go on registering for certification and go down the page, click here to access the register form. Then you can answer all the questions on the register form. And you also have access to your, sorry, to create your account thanks to the little man into the corner of your screen. And that's it for me. I saw that we only have one specific question, and Nicolas already answered it. If you still have question, you can send it to Nicolas or Conrado. And
There's one little new question about the greenhouse
sorry.
gas. I can show my screen. Do you see my screen?
Yes, I think
Yes.
so.
So yeah, the greenhouse gas emissions, specifically for co-processing. So here is the normal equation about the greenhouse gas. Is the extraction and culture of crops, the land use change factor, the processing for the production of intermediate products or fuels, the transport and distribution steps for the supply chain, and the use of this biofuel, plus the three bonuses that are for improved agricultural practices, carbon storage in geological sites, and replacement of fossil carbon by carbon in products. Here we have the specific equation for the co-processing. So we have the emissions of the upstream. So the upstream is, well, I will explain more in detail. The extra reagents that you use for the co-processing, because then in co-processing, you know that the feedstocks are biogenic. They are different from the fossil ones. They have, for example, more hydrogen. They have less hydrogen. They have more oxygen atoms. So you have to treat them differently. So you may need hydrogen, for example, to treat and co-process this. And then the emissions for the refinery itself, plus the transport and distribution of these fuels and the use of it. So if we break down the greenhouse gas equation, so the extra reagents, so if we have some hydrogen for the oxygenation or other chemical products, we have to take into account all the emissions that come from it, the emission factor of it. So there was a factory that created them, and then we have to take into account their emissions. So when we buy this bottle of a reagent, we need to take into account this background emissions. Then we have the upstream. So depending on which feedstock you use, if it's a virgin oil, Then there was a milling factory that produced this oil. Then there is a cooperative or a first gathering point that gathered these crops, and a farmer that grew these crops. So this is the addition of all these factors. So the EEC, the extraction and culture of crops, the land use, if the farmer deforested or changed the use of one of the zones of its exploitation. The P is for the milling, so the production of the oil. ESCA for the soil carbon accumulation following practices, the carbon storage, and the bonuses for the carbon storage and carbon replacement. So this is true for the HVO for biocrudes, but if you're treating with feedstocks that are waste and residues, their emissions, all these emissions are zero, because they are considered to be zero emissions in the point of origin. So after there is the collection and then this transfer until the refinery, it's only the refinery that you will take into account the emissions that you used for converting this biogenic fuel into diesel. I hope that that answers your question. If not, you can also text us more, write a question about it
I'm
here,
going to
or
put your
always to
email
write the mail.
Okay.
Yeah, to us. We are
Here.
always very available for any question that you have. If you find difficulties in the certification process, etc., we are here, yeah, to support you.
Perfect. Thank you so much. Thank you, everyone.
Thank
And
you very
if
much.
you still got question, you can ask Nicolas or Conrado. Don't forget, the support will be available on our website and the replay too. Thank you. Have a nice
Bye-bye.
day.
Thank you. Good night. Good evening. Bye.